I'm going to welcome Matthew Fish. Oh, shit. So he's going to speak about his new pet project. Well, it's more than a pet project. It's MacroFX physical memory analysis. And still, yeah, it's good. The new projector is going to warm up as you are. And welcome to Matthew. Thank you very much.
Okay, first, thank you for coming. Before I start, I have a few things to tell you. So, they're warming up, but there is a Twitter feed. So, if you want to follow the actuality about the conference, about the new instruction regarding the challenge or whatever, go on the Twitter challenge. There is also an official hashtag for Twitter, which is #HES 2010. And the second thing is, at the front desk, if you want, you can buy a t-shirt. So, you're welcome. Okay. So, first I'm going to introduce myself. So, I recently created my own company. I've done several different projects regarding Windows physical memory acquisition and analysis. And I recently released a tool called Moonsault Windows Memory Toolkit regarding Windows Hibernation file present and this kind of stuff. So if you are really interested into Windows memory data analysis, just Google it. So, as Philip said, I'm going to talk about MacroFX physical analysis. So, if you are more familiar with the Unix world, you probably know this device as DevMem. So what kind of people are really interested into physical memory analysis? So we have very different kind of people from a different background, like forensic experts, investigators, incident responders, mainly, and also malware analysis. So, why is physical memory so important? Mainly because the non-volatile memory, like the hard drive or this kind of stuff, is it's never enough. So with the physical memory, this is volatile information. So once you are logging to an application or running an application or whatever, it's always the physical memory. So this piece of hardware is very interesting because you can retrieve this kind of information. But the problem is this is a raw device. So unlike the hard drive, which has a file system, there is no real structure with the physical memory. So if you want to perform an analysis, it's very complex. And there is, especially on MacroFX, there is a lack of research into this field. So first, I'm only talking about a software method to get a physical memory done. So there is a big picture of what's going on. So first, you have an Apple computer like a MacBook. You are really interested into the RAM. So you have two possibilities to get a physical memory dump, like first, hibernation, using the self-sleep, as Apple people call it. And the second possibility is to use your own driver to access to DevMem and then to write it on disk. And then from the memory dump, you can work from your lab, and then you can extract the information you are interested in. So this talk is only about Intel processor, so it's not about PowerPC or this kind of stuff. It's only about macOS X Leopard and Snow Leopard. So, as I say, I'm not going to talk about FireWire acquisition, which is a bit more problematic because when you are using DMA with hardware acquisition, the physical address space is totally different. So the physical address space which is used by the processor, so you cannot really analyze it as you would like to. So the testmain device on macOS X is disabled by default unless you activate a special flag. But if you do that, you have to reboot your machine, so it's not really interesting. So the easiest thing, if you are using the kernel extension possibility, is that you have to write your own driver on bcopy underscore p is the function you are looking for if you are going to write a driver. So it's very basic, like you get the physical memory size and compile it. And as I said, the second possibility is to use the hibernation, which is present on every operating system like Linux, Windows, on macOS X. Apple call it the self-sleep because they